The periodic table is something that many people don't exactly know a lot about. Oftentimes you'll only see it in science textbooks and just think, oh, okay, I'm not gonna need that. But it's more than just a grid of simple substances, which is exactly why I've decided to make this video. I've already made a video on the history of the periodic table over on my now defunct channel, Scientifical, so this time around we'll just focus on the elements of the periodic table. However, as you probably might have noticed, there's a lot of them, so this video is going to be split into multiple parts. All things aside, let's get on with this video. Hydrogen is the most abundant element in the entire universe, with about 3/4 of the whole thing being nothing but hydrogen. The nucleus of a helium-4 atom, which contains 2 protons and 2 neutrons, has the same structure as an alpha particle. Lithium-4 has a half-life of about 91 yoctoseconds, giving it one of the shortest half-lives of any isotope. For a long time, beryllium had the name glaucinium, which comes from a Greek word meaning sweet. I really don't understand the correlation here because beryllium is actually toxic to the human body and can cause lung inflammation if inhaled. Even though it doesn't seem like it, boron is actually an essential element for plants, playing a key role in cell wall formation and pollination, among other things. Carbon is by far the most important element for life to exist, as basically every organic compound requires carbon in order to exist. 71% of the Earth's atmosphere is made out of nitrogen, which means that you're mostly breathing in nitrogen and not oxygen. Even though it doesn't seem like it, oxygen is actually the most abundant element in the Earth's crust, with about 46% of the Earth's crust being made out of oxygen, mostly in the form of oxides like silicon dioxide. Fluorine is the most electronegative element on the periodic table. What does that word mean? I don't know, figure it out yourself, I guess. Despite being one of the lightest elements, neon is actually fairly new to the periodic table, being discovered in 1898. Sodium, being an alkali metal, is very reactive with water. The atomic structure of sodium atoms allows them to react violently with water, as well as form bonds with halogens. In the case of sodium, the reaction with water forms sodium hydroxide and hydrogen gas. Magnesium is an element that the human body needs in order to survive. This is because it regulates many processes within the body, such as the function of muscles and nerves, regulating blood sugar levels, as well as blood pressure. Aluminium is the only element that can be recycled infinitely, and as a result, about 75% of all the aluminium ever produced is still in use today. That's almost 1 billion tons. Producing silicon of high purity requires the usage of coke. No, not that kind. There we go. Phosphorus was discovered accidentally in 1669 in Germany. The discoverer was actually trying to extract gold from their urine. Yeah, that doesn't really make a lot of sense. Sulfur may seem like it smells really bad, but in reality, pure sulfur is actually odorless. It only smells when you combine it with other elements into sulfur compounds. Chlorine may be a toxic element, but when combined with sodium, you get salt. Just regular table salt, no tricks or anything here, it's just regular salt. Argon is actually the 3rd most abundant gas in the Earth's atmosphere, at about 1% of the Earth's atmosphere being made out of argon, which is about twice as much as water vapor. One of potassium's isotopes, known as potassium-40, is notable because it actually produces antimatter. No, seriously, allow me to show you. Some, but not all atoms of potassium-40 will decay via beta plus decay. Alongside the byproduct of argon-40, this beta plus decay also produces 2 other things, an anti-electron, which we call a positron, and an electron neutrino. But this positron is what we're interested in, because it's antimatter. A banana is famously made out of a lot of potassium, and every 75 minutes, 1 potassium-40 atom will decay via beta plus decay. Despite antimatter being very expensive, this positron will basically disappear instantly after annihilating with another electron. So yeah, you're not going to be making much use out of this, are you? Calcium's most stable isotope has an equal number of protons and neutrons. This is the last stable isotope of any element to be like this. all other elements, most stable isotopes from here on out, will have more neutrons than protons. Scandium may be on the lighter end of the periodic table, but it wasn't actually discovered until 1879. 95% of all the titanium mined is used to create titanium dioxide. This material is a white pigment used in paints, paper, toothpaste, plastics, and many other things. When producing sulfuric acid, vanadium oxide is often used as a catalyst. While chromium in its pure form is pretty dull grey, many chromium compounds actually have a variety of colours. This is reflected in chromium's name, which comes from the Greek word chroma, which means colour. Manganese is another element, like magnesium, that you wouldn't think you wouldn't need to survive, but you do, you need it to survive, as it regulates macronutrient metabolism, bone formation, as well as free radical defense systems. Yeah, I don't really know what any of those mean, but sure. Iron rusts when exposed to air. That's not really a very unknown fact, but most people don't really know why this happens. What's really going on here is that iron is reacting with the oxygen in the air, creating iron oxide. That's what rust actually is. Roughly 3/4 of the world's entire supply of cobalt comes from just one country, the Democratic Republic of the Congo. The metals inside a US nickel and penny, which are nickel and copper respectively, are actually worth more than the face value of the coin itself. The US nickel is worth about 9 cents, with its face value being only 5, and the penny is worth just a little bit more than 1 penny. Roughly 13 million tons of zinc is produced every year, making it the 4th most produced metal in the world, behind copper, aluminium, and iron. Gallium has an infamously low melting point of only 30 degrees Celsius, 85 degrees Fahrenheit. With this melting point, just putting gallium in your hand would be enough to melt it. Out of all of the elements in the Earth's crust, germanium is the 50th most common. Arsenic was actually very commonly used throughout the 19th century. This is because it was commonly used as a green pigment, used in Paris green and Scheele's green in the late 18th and early 19th centuries. Back then, people were completely unaware of the toxicity that arsenic posed, and as a result, many people died due to exposure to things containing this green pigment. I would recommend watching this video here by Ted Ed, which does a much better job in explaining this chemical than I just did. Despite having no connection to the moon at all, selenium's name actually comes from the Greek word for the moon, which was selene. Bromine's 2 stable isotopes occur at very similar levels naturally. The narcotic potency of krypton is 7 times greater than that of air. Narcotic potency is basically just how good of an anesthetic it is. Rubidium, being an alkaline metal, reacts violently with water. However, rubidium is notable because it's the first of the group to actually have a higher density than water. Strontium is an element that is toxic to humans. I say toxic in quotation marks because not all forms of strontium are actually poisonous. The problem comes from radioactive isotopes of strontium like strontium-90. Because strontium is chemically very similar to calcium, strontium can sometimes end up inside of bones if ingested. And this is not good if you happen to ingest a radioactive isotope. And it's actually even worse if you happen to be a child, because it can sometimes lead to bone growth problems. Yttrium is a very hard element to find because it doesn't actually occur very frequently in the Earth's crust. Only about 31 parts per million. On top of that, it never occurs on its own. It's always bound in something. And there's only one stable isotope of it. About 1% of all the zirconium on Earth is used as nuclear reactor fuel, which seems a bit odd considering you wouldn't really think this element is radioactive. So that's the first 40 elements of the periodic table completed, meaning we're about 1/3 done with the periodic table. So stay tuned for the second part, where, if it ever releases, we'll take a look at elements 41 to 80. Thank you for watching, this has been Topic AL, and I'll see you all later.